Molecular dynamics is a popular method to simulate the time evolution of an atomistic model. Within the molecular dynamics framework, the temperature of the system has to be equilibrated with the help of a thermostat. Here I have a small simulation box filled with ethanol molecules. I'm going to run a molecular dynamics simulation with the reXFF force field, but any other AMS engine, be it ADF, machine learning potentials or something else, will work in the same vein. This is the settings panel for the MD driver. Without any thermo or barostats, a closed-up NVE or microcanonical ensemble will be calculated where the number of particles, the volume and the total energy are kept constant during the course of the simulation. Once we do define a thermostat, energy is allowed to enter or leave the system and an NVT or canonical ensemble is sampled instead. In AMS we have the choice between two thermostats. The Berendsen thermostat will ensure a rapid convergence of the temperature, but the resulting velocity distribution will not be correct. The Berendsen thermostat is a good choice for heating up or cooling down a system that is far from the target temperature, but for studying a system at a specific temperature, it is usually not the optimal choice. The Berendsen thermostat is often used with short damping constants in the order of around 100 femtoseconds. However, setting the damping constants too low is known to result in severe artifacts that may even lead to a flying ice cube effect where all kinetic energy is wrongly transferred from vibrational into rotational degrees of freedom. The Nose-Hoover thermostat, on the other hand, is guaranteed to sample the correct ensemble, but it will take a bit longer to equilibrate. For the Nose-Hoover thermostat, the damping constant should roughly correspond to the correlation time of the system. That's the time it takes for the system to forget a disturbance. In liquid water this is 2 to 3 picoseconds, and for solids it's up to a couple of hundred femtoseconds. Setting it longer won't hurt, but it will make the thermostat settle slower. So that's it for today. As usual, we'll put some links to background information and more best practice advice into the video description and are happy to answer your questions below the video.